So welcome to this introduction to Micronaut. So I call this talk Micronaut Launchpad. This is the first time this talk has been delivered. And it's a little ambitious because there's a lot of things I want to show off and talk about and not that much time to do it. So as a result, we're going to be a little lighter on demo. I do have a couple of demos I'm going to try to get through, if at all possible. Not here to talk about me. So my name is Zachary Klein. I work for OCI. And we're a consulting company out of St. Louis. And we also sponsor a number of open source initiatives, one of which is the Micronaut framework that I want to talk about this afternoon, morning, whatever time it is. So let's get right into it. So Micronaut was announced in March of 2018. It went open source later that year. We had a 1.0 release in October of 2018. And it really got a lot of people excited. And there's been a lot of discussion, a lot of innovation, a lot of interest in how can we make JVM apps more performant, have a smaller footprint, and be a better fit for the new, very cloud-centric development and production patterns that are developing. And so there's been a lot of advancement in this area, and Micronaut was there pretty much right at the start. And version 1.3 was just released this month, in fact. And we also rolled out Micronaut Data, which I will basically not talk about at all because there's another presenter tomorrow who will be talking in depth on Micronaut Data, but we'll mention that as well. So that just went 1.0 this month as well. So development is active, the community is growing and very active, and there is a lot to talk about. Micronaut continues to show the path forward, I think, for server-side Java in this new era of cloud-based development. So what is Micronaut? Well, if you gave me 2 words, they would have to be microservice framework. But I really want more words, okay? If you give me 4 words, I would say a Micronaut and serverless framework, but I still want more words. But at its core, yes, it's a framework for building microservices, serverless applications that run in a cloud-based distributed environment. That's really its reason for coming into existence, right? So what makes Micronaut special? We're going to talk about that. We're going to talk about a number of features of the framework. And then we're going to try to get, like I said earlier, a survey of the ecosystem. There's a lot of stuff out there already, a lot of integrations, a lot of libraries that are based on Micronaut or that make use of it. And we're going to try to show as much of that as possible in the next 45 minutes or so. Since it is a web service framework, we do have an HTTP layer involved. And in Micronaut's case, that is based on Netty, which is a reactive HTTP library. We handle both a server and client. So I mentioned earlier, we're targeting the cloud here. And so a service is not just a service, it's also a client. And that's just part of the development experience with Micronaut. We handle both sides of that relationship. And the phrase we like to use when we're describing Micronaut is that it is natively cloud native. What that means is that it assumes that it's running in a distributed environment. And there are features baked right into the API, to the core framework, that handle very common scenarios that happen in a distributed environment. Things like retryable, things like circuit breakers, things like load balancing. Those are not secondary or adjunct concerns, they're primary concerns in a full Micronaut application. And so we say it's natively cloud native. But Micronaut also encompasses a broader ecosystem that's been developing with a lot of other libraries for things like data access, Kafka, RabbitMQ, a number of things. So we're going to go through some of that. What can you build with Micronaut? Well, obviously microservices, it's kind of suggested by the name, and serverless applications. Those were really the primary interest of Micronaut when it came out. But there's a lot more you can do with it turns out. One thing that we've been experimenting with lately is message-driven applications. So you can think of microservices, but instead of using HTTP, we're using maybe Kafka. And so you can build services that don't even have an HTTP server. And that goes to Micronaut's modularity. It's not all or nothing. And there's portions of Micronaut that make sense for certain kinds of applications and other parts that might not be necessary. You can build CLI applications. You can build Android applications. And pretty much anything, if it's got a static void main, you can use Micronaut. It's very flexible and has a very broad appeal. What makes Micronaut different? So Micronaut, as I said, was designed for a distributed environment. So it was really looking towards the future of how applications are being designed, architected, and developed. And the key innovation, really, that Micronaut brought was it was a full-featured web framework that embraced ahead-of-time compilation. And what this means is that framework magic, if you will, things like dependency injection, aspect-oriented programming, things that were typically done through the generation of proxies or through reflection at runtime, all that framework magic that we are accustomed to as Java developers and that makes our lives a lot easier. We don't want to give it up, but it has a cost. It has a cost, especially when it comes to firing up your service and to runtime. It's got the framework has to do a lot of stuff behind the scenes to give you that programming model and that API that you're comfortable with and that we all enjoy. So what does Micronaut do? Micronaut does the same sort of magic for you, but it does it at compilation time. And that means that things that normally would happen while the application is either starting up or while it's running, those things are now baked into the bytecode of your application. And that drastically reduces the amount of stuff that the framework has to take care of when your application is actually on the stage and doing its job. And that's really where most of Micronaut's benefit comes from. A lack of reflection, runtime proxies, class loading at runtime. Now these changes and this emphasis makes Micronaut a very natural fit for alternative VMs such as GraalVM. Because Graal does not do runtime reflection. It doesn't. That's the big reason why it has the performance that it does. And Micronaut fits very nicely with that kind of a model. We'll talk a little bit about that in this talk. Micronaut is reactive in its architecture. So reactive programming is not required for Micronaut, but it works very well because the framework itself is built using reactive practices. I mentioned already it's capable of running with very little memory, and we'll talk a little bit about startup time in a minute, but general rule, you're talking sub-second startup time with a Micronaut service. And additionally, it is a polyglot framework, so though it is a Java framework first and foremost, it supports Kotlin and Groovy as first-class languages, so you can use those to write your Micronaut applications. A few numbers just to give you an idea of the kinds of metrics we're talking about. With the latest version of Micronaut 1.3, we're seeing startup times of around 800 milliseconds just with plain JDK 13. No tuning, no options. It's around 800 milliseconds. And as a native image, we're seeing in the teens of milliseconds. And you can see the memory estimates there as well. Again, there's a lot of variables here, and we're working on having a more robust way of tracking. We have ways of tracking the performance over time, but that's giving you some idea of what kind of numbers we're talking about with Micronaut. All right, so let's do a quick hello world demo here, hopefully. And as the previous presenter mentioned, this podium is not designed to make live coding easier. So let's see if I can first get us a more reasonable display resolution. So what I want to do is I'm going to just go ahead, I'm going to use the Micronaut CLI, I'm going to create an app from scratch, and we don't have a lot of time, so I can't go very far with this, but I want to create a few things and kind of get you a sense of what the API looks like. Let's see, am I mirror displays? What are you guys singing? You're singing, okay, good, we got mirror displays, great. Now let's just change the resolution to something hopefully a little more legible for all you. How's that? Is this a reasonable? Oh, that's a nice shade of blue. Okay, hang on. Come on. Okay, how's that? Can everyone read that? We good? Okay, let's go. So I'm going to CD here into my dev directory. And I've already got the Micronaut CLI installed. There's multiple ways of installing Micronaut. You can install, if you have a Mac, you can use Homebrew or Mac ports. You can install it using bash. There's a curl command you can install. You can just download this distribution yourself and set up your path. The way I like to handle it is with a tool called SDKman, which if you have not checked it out, I recommend it, sdkman.io. And it's a tool for installing Java frameworks. It's got all sorts of stuff there that you can install through SDKman. So if I SDK list Micronaut, I can see the candidates that are available. Looks like my power is not plugged in, or hopefully we're okay here. So you can see there's the Micronaut versions that are available, the ones I have installed, and I'm currently on 1.3.1, which is the latest version. So this is the easiest way to get a hold of the Micronaut CLI. So we'll go ahead and start that up. Let me check my Java version really fast. It should be on OpenJDK 13. That is the case. So we'll go ahead and type mn. And Micronaut CLI is interactive, so you can run commands or you can just run the CLI by itself and you get this nice interactive mode. A great way to just kind of play with the CLI and see what capabilities it has. So right away I can see that I have a number of create apps, or create commands I can run. So I'm going to just go ahead and run create app. I'm going to call this, I think I already have something called Devnexus in this directory, so I'll call this 2020. So and actually I'll give my app a default package. How about that? So com.example. All right, and then I can add features to my application. So if I hit tab here, I should see a list of the features that are available. These are just the features that are available with the default profile. So there's other profiles you can use to add other options to when you're generating your application. So for this one, let's say I want to add management. I'll explain what some of these do later on. Let's add file watch, and is there anything else in here I want to throw? Let's add, I believe it's called Open API Java. See if I got those all correct. I'm just going to take the defaults. Oh, made a mistake. Okay, hang on there. Well, it's going to create that anyways. That's all right. It should still be okay because I just won't have that feature that was mislabeled, but I can add it myself. It's not a problem. Okay, so we don't have time for much else, so I'm just going to jump out of the CLI now, CD into our new application. Oops. Again, pardon the typing here, a little tricky. Okay, there we go. You'll notice that this is a Gradle project by default. The CLI can generate Gradle or Maven projects. Are you all getting this mic, the room mic? Okay, so I guess I got to keep mine where my mouth is. Okay. All right, that's fine. So Maven is also, I personally prefer Gradle, so that's what I'm going to use, although I will admit that you get slightly better performance with Maven. So either of those are first-class citizens. Let's go ahead and open up this project in the IDE, because that'll be a little easier for me to navigate. I'm going to probably have to shut down that project I have running over there too. All right, so here we go. So I'll open up my build.gradle file and import my project, and we'll take a look around. And while I'm doing that, I'm going to shut this other project down, because that's for later. Okay. And IntelliJ is thinking that I need Android for some reason, so pardon that. So actually at this point, I think I'm going to do, hopefully you guys don't mind, I'm going to jump to a different project just because I don't want to fight the IDE. So this project here is essentially the same one that I was showing you. I created it the same way. But I have a few things in my Git history that will make it easier for me to quickly demo a few things. So what I want to do, I want to go ahead and create, so notice that in this other project, my default, my package is now hello.world. So let's go ahead and create a controller. So I can actually do that through the CLI. There's a command to create a controller, but I'm just going to create the file myself. So I'm going to create a class called hello_controller, and let's make this a controller. So we have a controller annotation, specify our path. Let's put this at the root path for now, and then we're going to add a method to our controller. Let's say this. We're going to return a string, and we're going to call this index. We'll take a string name, and we're going to return a obligatory greeting. There we go. Exclamation point. We're excited today. And now we're going to specify this is going to be a GET request. So there we go. So there's our first little controller. Let's go ahead and fire up this application. And I'm going to run it with the continuous flag in Gradle. I'll mention this later on when we get back to the slides. This is going to give me an automatic restarts as I make changes to the application. If I spell continuous right, that should be just fine. All right. So what are we looking at here? So now we've defined a controller. It's at the root path. It's got a single method to it. It's going to return a greeting, and it's going to use a query param named string to populate that greeting. So Micronaut's up and running now. Let's go ahead and take a look at something real quick here. So notice, let's see if this is the right place. Well, you know, maybe I might not want to go down this path. Might get a little bit too hairy, because we're going to start relying on the IDE more than I probably should. So what just happened, though? When we compiled the application, Micronaut analyzed the code base, it found my controller, and it created that controller also exists as a bean within the dependency injection container, right? And so it's going to create a bean definition for this controller, and it's going to do whatever logic needs to be in place to allow this controller to serve the requests that we want it to serve. And it would do the same thing if I was defining a client that called to a third-party service or what have you. At compilation time, Micronaut is analyzing this code and generating the necessary implementations so that when I go to actually run the application, all that work has already been done for me. Let me go ahead and see if this is actually up and running. I'm seeing that my battery is depleting, so I may take a break here shortly just to make sure I'm plugged in. Let's go ahead and pass in our name param. We'll say Devnexus. Let's see, did I leave something out here? Oh, I know I left out. I think I may have needed to specify that Git was also on the root. Okay, so it just restarted for me. Let's go back over here. Page not found. This would be a lot easier if I could see my screen, so I apologize here. Okay, so our controller, returning, am I in the wrong? Oh, great catch. Okay, you know, that's a good example. So here's where I went wrong. I neglected to tell Micronaut where this argument was coming from. So that was my mistake. So there's a syntax where you specify the query params, and there's a whole API for handling, you know, if you're posting JSON, all that. It supports everything you'd expect a good REST service framework to support. So that was just an oversight on my part. Let's try this again. There we go. That's what I was looking for. So there's our first controller. And then real quickly, I want to create another controller, actually. So I'm going to create a controller I'm going to call, let's call this home controller. All right, and so what I want to do now is I want to demonstrate the client features in Micronaut. So I'm going to create a new controller here. This is going to supplant the one that I created previously. It's going to have a similar convention though, so this is going to now be served at the hello path. And then this one will be our home controller. Now what I want to do is I want to make a call to my previous controller, the first one we created, to actually get back the string, and I'm going to return that from this secondary controller. Now this would be more interesting, of course, if this was happening in another service, but the API is identical. So what I'm going to show you here would work regardless of whether or not this was a controller in my application or a controller in some other service or Twitter's API or anywhere else. So let's go ahead and create this interface. We're going to call it Hello Client. I'm going to add an annotation here, @client. Now again, I mentioned in this case, I'm targeting another controller in my application. So all I need to do is give it the relative path. If this was a third-party service, I would put in their API here. If I was using service discovery, I put a service ID here. If I wanted to make this configurable, I could put a configuration property here. So however you need to get a hold of the actual service you want to call, the client annotation will serve you well. And then, since this is a client for a hello controller, I'm just going to copy my method declaration. And you might be thinking, there's some really good applications of what I'm doing here. Because what I'm showing is that the API for declaring a controller is identical to the API for creating a client to consume that controller's API. And so you can do some really cool code sharing things with that fact. So now I've got a hello client. This will also be a bean in our context. So now if I go back to our home controller, what I want to do is I want to inject this client. I could inject this using a constructor, by the way. A constructor argument would work exactly the same. But I like the inject annotation, so that's what I'm going to use for now. So I'm going to get rid of this. Okay, so what we're doing here, now our home controller is injecting the hello client, which itself is going to be consuming the hello controller we defined earlier. So now, and I'm going to make this clear what's going on by concatenating the string. So I'm going to say message from hello client. And it's going to be hello client index. We're still going to pass in the name. And there. So that's going to recompile now as I save. And it's going to double check, make sure I didn't forget anything this time. Oh, I did forget a semicolon. Yes. At this angle of the screen, I can't see reds. So that's going to be interesting. Okay, there we go. So we're up and running now. So now if I go to the same URL, we should see message from hello client. So we are now talking to that new controller, which is making another HTTP call to its neighbor through the client that we just defined. Last thing I want to show here. Let's go over, and I'm going to use my Git trick because I don't want to make you watch me type a big long annotation. How many here are familiar with OpenAPI or Swagger? Do those names mean anything to you? Okay, good. So there's a tool for documenting REST APIs. So what Micronaut can do so we have an integration available for OpenAPI. And what Micronaut will do is when it analyzes your code base to do all the framework stuff it does, it can also generate a OpenAPI schema. And so I'm going to go through here. I have to turn on some configuration. So this is just basically, this configuration here is just so we can see the OpenAPI pages, hopefully. So that's not particularly specific to Micronaut. And then if I go over, I got to go to our build.gradle file. And I'm going to restore these things. These are the dependencies we need. So we have the Swagger library itself. And then I have one last bit of configuration to make to actually expose the schema. So that should be all we need. And let the thing recover. We did a few big changes here, so it might take a minute for the reloader to come out of this. Let's see, is it still working? Just in case, I'm not going to wait for it to reload. I'm just going to go ahead and start it up again. So there we go. So notice I didn't actually document my API, though, right? I have not added any more metadata. All I did is just, the only thing I had to add is I had to add that sort of top-level OpenAPI definition. So Micronaut will look for this to know whether or not it should create your schema. But that's all I've done. So let's go ahead and see if this got us what I'm hoping for. Let's go to Swagger UI. And nope, because I neglected to take care of a routing problem that I should have. I'm just going to make that go to the home directory. Oops, homey. Okay, that shouldn't take long to reload. Let's try that again. Give it a moment here. The reload you have to wait for. So the way the restart works, and I was going to mention this in the slides, but I'll mention it now, is that it actually, oops, is it still, there it goes. Is that it's actually, Micronaut is basically letting the build tool know there was a file change, and the build tool is actually doing the reloading. So there it is. There's our Swagger documentation. There's our 2 endpoints. This is not a tutorial on Swagger, so I won't walk through all that. But the point is, I didn't have to document the API. The API was basically self-documenting, and tools like OpenAPI were able to turn it into a reasonable start, at least, for API documentation. And of course, you can customize it to your heart's content. That's not a problem at all. You can add your own annotations and substitute what Micronaut generated for you. All right, we got to jump back into the slides. We got a lot to go through. Let's see, what are we at? 11:45. All right, we already talked about installing the CLI. I recommend SDK Man, but there's other methods, and if you go to the website, we'll make that pretty straightforward. It's a great way to familiarize yourself with some of the features that are available and some of the integrations that are available. So we got a command to create a service. As I mentioned, you can create services in Java, Groovy, or Kotlin as your application code, your language rather. And then you could also supply optional features. So in this last example here, we're creating a Kotlin app that has a distributed tracing enabled with using the Jaeger tracing library. You also have a command for creating multiple services. So you can create more than one service in a single command, all with the same CLI features applied, or same language features. So then you could, earlier I mentioned that we generate projects with either Gradle or Maven, and so you can fire those up with the appropriate commands depending on your build tool. And I mentioned hot restart. You got to see it in action a little bit, and there's no real magic there. It's just Micronaut using a file system tool to indicate that the code source has changed, and then the build tool is actually doing the reloading. So Micronaut itself isn't doing that, but we have the ability to turn that on pretty easily. So again, this is all documented in the user guide as well, but there's a different method depending on if you're using Gradle or Maven. Gradle has a better change detection built in. With Maven, we have to use a simple shell script. So we saw Hello World already, so let's look at this one more time. We got a controller here. Notice we're using another annotation that I didn't use last time. We have annotations that indicate the response type, the kind of content that you're producing. So in this case, we're saying it's text plain. By default, it's application JSON. There's a consumes annotation that does what you expect. It specifies the file type we're expecting. For testing, one of the cool things about Micronaut is because it reduces the overhead in starting up your application and in running it, it makes testing actually pretty trivial when firing up the entire application. So what I'm showing you here right now is really an integration test. So the @Micronaut test annotation, which works on either JUnit or Spock tests, will actually fire up the application, execute the tests, and shut it down for you. And because of Micronaut's low startup time, that happens in about as long as you expect for a unit test. But it's actually more properly an integration test. Now, of course, you can still write unit tests with Micronaut, and that's perfectly advisable. But this is a simple example of how you can create a test that actually starts up your application, makes requests against the real running app, and you can then assert the results. So let's talk a little about the dependency injection, because that's really where a lot of the magic happens. So Micronaut implements JSR 330, otherwise known as the Java inject annotation set. And so that's where we get things like @inject, @singleton, and there's a whole suite of things that are available under that package. Micronaut implements all of those. As I mentioned earlier, all of the analysis and all the metadata generation for doing the DI happens at compilation time. And very similarly, AOP capabilities are handled the same way. So we can have things that run, you can have advice that runs before or after a method is called. And you can add behavior to other classes using AOP. We got a question? Yes, it is annotation processing. That's what's going on. So I haven't mentioned the technical details. There's a little caveat because we do support the Groovy programming language. And in Groovy, we don't have annotation processors, so we have to do the same thing a different way. But yes, it's annotation processors. That's what's happening. So here's a simple example. This is, we're declaring a service that's a singleton. So that bean definition for this service is going to be created when the app is compiled. Then we're injecting this into a controller, and we're calling it and returning it as part of a controller response. Now, again, what makes this interesting is that the logic that actually figures out, okay, weather service is required by this controller, and whatever other dependencies that weather service might have, whatever clients it needs to talk to actually make its request out to an API to get its information, all of that is figured out at compilation time. The HTTP logic for doing client calls and for handling HTTP headers and for parsing a JSON response or whatever, all of that is figured out at compilation time. So Micronaut creates a bean context, as you might expect. In addition to just injecting a bean directly like we were seeing, you could also inject an optional of a bean, an iterable of beans. So it's a very full-featured DI container. Beans can be qualified. So you can, if you have multiple beans of the same class, you can have, or have the same parent class, you can qualify which one you actually want to inject in a certain situation. And beans can be made conditional, so you can have certain beans that are only created if a configuration property is set, for example. And you could also specify beans as fallback. So you can say, well, if I can't fire up my weather service bean because I'm missing a configuration property, here's a fallback service that will return a not available message or something like that. So that's also supported by the DI container. As I mentioned earlier, Micronaut is built for a distributed environment, and so generating a controller and a client are just as common and really use the exact same API. I won't talk more about that because we already looked at it in code. Clients can be defined using an external absolute URL. They can use a service ID if you're using service discovery, or you can use a configuration property to indicate who they should be talking to. Service discovery, Micronaut is, again, very flexible here. It abstracts service discovery by use of something, an interface called Discovery Client. So how that's implemented will depend on what provider you're using. If you're using, for example, AWS, Route 53 for service discovery, or most of my examples, I'm using Consul from HashiCorp. Eureka, Zookeeper are supported, and container runtimes, obviously Kubernetes are of course supported. And when there's multiple instances of a service that are registered, Micronaut automatically load balances between them. So even load balancing is a core framework feature. If we've got 3 instances of a service, we're going to cycle our requests through all of those instances. Another question? We do. The distributed configuration? I've got a slide on that later, but yes, we do. So I'm not going to, hopefully we're all here familiar with how service discovery works, so I'm not going to talk through all that. But the cool thing, again, is that Micronaut abstracts that. And so the discovery client interface could be implemented by any library or by you yourself if you have a very specific service discovery solution that you need to accommodate. But we do have some very common ones like Consul are supported very simply. So here you can see the configuration. We're just basically telling Micronaut where to find Consul, and assuming that Consul is up and running, our service will be registered with its application name as a service ID, and now this service is available to other services that are also registered by simply referring to that service ID. Again, part of being in a distributed environment is recognizing that things don't always work, the requests don't always go through, and you've got to have a nice way of dealing with that kind of situation. And so Micronaut has several annotations that help you deal with those sorts of issues. So the retryable annotation will automatically reattempt a method call for a configurable number of times with a configurable delay. Evolving on that is the circuit breaker annotation, which does the same thing, but with the additional feature that after a set number of failures, rather than continue to ping that downstream resource or service with futile requests, it'll actually begin just instantly returning the last thrown exception to all callers until that delay has expired, at which point it'll try again. And that gives the downstream service a chance to maybe recover if it's a database or something that's got too many connections. It gives that service a chance to get back online instead of swamping it. Yes, question? We do have support. It can use Hystrix, but by default, it's a Micronaut implementation. Yeah, it's a framework feature. Configuration. So we saw a quick glance of the application.yaml configuration file, which is the default configuration file in a Micronaut app. Micronaut accepts a lot of configuration formats, so you can do YAML, you can use JSON, you can use Groovy, which is more interesting than it might sound because it lets you actually do some imperative logic in your configuration if necessary. You can make, for example, we have one demo where we make a request out to Google Cloud to resolve some metadata and then load that in as configuration. And of course, it also gets configuration from system properties in the environment, and it can handle distributed configuration. So there's a sample configuration file there, and we're not going to walk through it in great detail, but here you can see an example of how you can inject configuration. You can use this @value annotation, which takes in the configuration properties that you want to inject together with any default values. And then if you have more complicated configuration, a cool thing you can do, so if you have like maybe sort of a nested configuration, or if you have a map or a list, you can actually define a class. So a Pojo, for example, that maps to that configuration file. You annotate this class with configuration properties, and now this configuration properties becomes a bean in your context. And so now I can inject this bean. Now I have an instance of a class that has my configuration properties rather than having to map to individual keys from a file. So that's another way of accessing configuration. Now, distributed configuration is very cool. So this allows you, so again, Micronaut abstracts this away by way of a configuration client interface, which itself will then resolve configuration from whatever distributed sources you configure. And so we have integrations already available for console, which we already mentioned, for Spring Cloud and for AWS parameter store, sorry. And then there's other options as well. So it's, again, because it's abstract, you can implement your own provider for the configuration, distributed configuration. But once this happens, so when the application is running, that configuration client will now expose those remote configuration properties to the application, and they can be injected just as a local configuration property would have been. There's a CLI feature, again, that you can, or there are CLI features for some of the common providers, like console, that you can use when you create your application. Otherwise, it's actually not particularly hard to configure. You really just have to enable it in your configuration file. Although one thing I should mention, and this is similar to other frameworks, is that the distributed configuration config belongs in a different file called bootstrap.yaml. And now if we populate that config server with properties, they'll be available to our service, just like we expect them to be. Oh, well, my coffee, just give me a moment. Monitoring. So Micronaut has a module called management that adds similar endpoints to what you might see in Spring Boot with the actuator. So we have endpoints that return the beans in the application context. We can return health metrics. We can return all the routes that are configured in the application. We can return all the loggers that are available, and we can even change log levels at runtime, and we can shut down the server. So there's a whole bunch of things that are exposed as endpoints by this management module. And of course, you can create your own endpoints as well, or add additional information to the existing ones. And of course, to use things like metrics, you will have to have a metrics library. And so the one that we recommend most often, because we have good integration, is micrometer. So you can return application health and metrics that way. Again, CLI feature is a simple way to add it to your new application, or you can add the dependency yourself. One thing to note is that if you're using the security library, then endpoints are secure by default. So you have to be authenticated in order to access them. Got a tickle in my throat, so I apologize for that. And one comment I should make is I have lots of URLs here in these slides. The slides will be available, and I highly recommend, because I'm going so fast, get the slides. They should be a good resource for you, because they'll point you to a lot of tutorials and other things that we have that will give you a lot more detail in how to do some of the things I'm talking about. At this point in the talk, I'm really just trying to show you a whole bunch of things so you kind of know what's out there, and something might spark your interest that you want to look into yourself. Distributed tracing, this is super cool if you've done any work with microservices and you have not looked into tracing. I highly recommend you look into it just as a general practice. So the idea here is that you can do sort of a logging through your microservice architecture and actually follow a single request, a user request, through your entire system, and store metadata in that what's called that trace, and it gives you a lot more detail on potential performance bottlenecks and other issues with your application's architecture. And so Micronaut supports the open tracing spec, and there's multiple libraries that follow that specification. And then we have special integration with both Jaeger and Zipkin. Again, there's a CLI feature to add it to a new application, or you can add the dependency yourself. And a cool thing about the Micronaut user guide is that we always show you both options. So if you're creating your new app, here's the feature. But if you have an existing application and you want to add it yourself, here's the config or dependencies you need. So once tracing is enabled, Micronaut provides several annotations that let you actually customize the trace, add metadata, or tags as they're called, and kind of control how the trace is subdivided. If I want to create a new segment in my trace for a specific method call, or if I want to fold that method call into a longer span. And we also defines an instance of the tracer interface, which is defined by open tracing, so you have complete under-the-hood access to the tracing library that you're working with. And then, of course, you can view your trace results through the pretty UI provided by the library. We already looked at the API, open API features, so I'm just going to kind of breeze through those. Again, the idea is that Micronaut at compile time is analyzing your code, and anything we can do at compile time in Micronaut, we do it at compile time, and that includes generating your API documentation and optionally serving it up over the server if that's the way you want to handle it. Micronaut for Spring. So because Micronaut works on this principle of analyzing your code base, looking at these annotations and doing all this computation and generating this metadata and bean definitions and all of that, it all happens at compilation time, we can look for other annotations. And so that allows us to write integrations that can look at annotations from another library or another framework and map those annotations to the appropriate behavior that they would have in a Micronaut application. And so you can use the Spring annotations and get the same functionality implemented through Micronaut. And this gives you a lot of possibilities. This makes it, this is especially useful for people who are developing libraries, because you can create a library now that is compatible with Micronaut and Spring with no code change in the actual library code. It actually, and we have, you can look this up online, and we have demos of this. You can actually run a Spring Boot application as a Micronaut application. So it's not entirely complete in that there's still some edge cases and things to be aware of, but it's a very compelling capability. And this also allows you to do useful things like exposing Micronaut beans to a Spring application. So I can write a library in Micronaut, or I can use a module from Micronaut, and I can expose those beans in the Spring application context. And now I can actually make use of Micronaut beans in my Spring application. And where this becomes useful is if you want to pull out certain features out of Micronaut. Maybe you really like the HTTP client we were looking at earlier. That can be used within a Spring application. So Micronaut for Spring is worth checking out if that's interesting to you. As I mentioned, there are a few limitations. Aspect J is not supported, so you have to use Micronaut's own AOP API, and Spring Expressions and anything doing with servlets is not going to be supported within Micronaut. Micronaut data. I'm not going to talk long about this at all because there's an excellent talk coming up tomorrow that I'll mention at the end. Todd Sharp is going to be giving you a deep dive into Micronaut data, but it's a persistence framework written in Micronaut. And again, the key selling point here is that ahead of time compilation. So rather than generating your queries, for example, at runtime or when you make a call and figuring out, okay, what SQL do I need? All of that is happening at compilation time. And so that allows Micronaut data to provide really good type checking, and it just gives you better performance because you don't have the runtime overhead of a lot of data access frameworks. And it's also, like many things in Micronaut, it's natively reactive, and so you can do reactive queries. That's a quick example of a repository. Again, I'm not going to talk much about that at all because tomorrow in this room at 10:20, Todd Sharp will be giving a deep dive into Micronaut data, and I highly recommend you check that out. So moving on, I don't have good clock here. Where are we? Where are we for time? So we have 15 minutes or 10 minutes? 15, okay, good. We're not that bad then. All right, great. Okay, so Micronaut apps are set up by default. If you're using Gradle, they're making use of the Shadow Jar plugin or the Shade plugin if you're using Maven. So the default way of packaging your application is to build an executable jar file, and that jar file then can be deployed to whatever platform that you're interested in. So we have documentation available that I'll mention in a moment for AWS and for Google Cloud and for AZURE. GraalVM, how many here are familiar with GraalVM or at least interested in it? There's a few hands. Okay, there's a lot of talk about it these days. And so this is not a GraalVM talk. I'm not a GraalVM expert, so I don't want to totally mess up your perception of it. But it's an alternative to the normal JVM. And what it does is it gets rid of a lot of it brings your Java code a lot closer to the native machine, right? So a lot more things are happening at a lower level, and this gives you the potential of having Java applications that have insane performance at the cost of some of the features that we're used to in Java, and especially that frameworks are used to having. One of those being runtime reflection. And since Micronaut avoids runtime reflection, Micronaut applications are pretty much by default a great candidate for running on GraalVM, and you can see even further reductions in startup time and memory consumption, as I showed earlier on a previous slide. And so we have a CLI feature that, so to create a native image, there's a little bit of work involved. And so there is a CLI feature that will give you a script that will take your jar file that we produced with that earlier example and package it and create the native image. And then you can now execute that using Docker, for example. And we can see this is an actual a run that we did. And we had a base Java Micronaut application starting up in 12 milliseconds. So you can see some.
We were having locksmiths come and are going to verify all the locking devices that will be.
That was interesting. I'm not sure that happened. I guess Siri activated in my pocket. Sorry about that. Okay. So GraalVM. Okay. So I mentioned earlier we have integrations with a lot of cloud providers. Now, basically, you have a executable jar file, and there's not necessarily a lot of framework integration you need. But we do have some pretty useful features. One that's especially cool is that Micronaut knows when it's in the cloud, and it even knows which cloud it's in. And so you can have configuration files that are specific to AWS or to Google Cloud, and there's a whole suite of cloud providers and other environments that Micronaut can detect. And so you can have custom configuration for those environments. For Amazon Web Services, we have great support for creating Lambda applications, or Lambda functions rather, and that's especially cool if you're interested in building GraalVM Micronaut apps that run on AWS Lambda. It's that you can do some pretty cool things. And we have official documentation on how to do this. And in fact, we actually have a number of examples available on GitHub that I'll mention as we get to the end. And there's a CLI profile as well. So where I said create app, I could have said create function, specified AWS as my target, and it would have generated a Micronaut application that's already configured to work as a Lambda function. We also have the same sort of environment detection for Azure, and Microsoft provides a Maven plugin that makes deploying to Azure pretty easy. And we have a guide available that demonstrates how to do that. And for Google Cloud, similarly, Google Cloud provides, in this case, it's a Gradle plugin, and that I'm hoping to demo here shortly, that will allow us to package and deploy a Micronaut application to Google App Engine. So there's a lot of information available to you for targeting cloud platforms. So actually what I want to do now is see if we can go ahead and deploy an application to Google Cloud. So I've got this already configured. I just did this last night, so this is fresh off the presses. And so let's see how far we can get. I'm going to go ahead, and this is actually going to all happen here in the terminal. So let me first pull up my Google Cloud page here. There we go. So I've gone into my Google Cloud account, created a project. I have the SDK installed locally here. So this is all just defaults. I haven't really changed anything. I'm just going to go into my directory here and cd Devnexus. I believe it was this directory right here. So I'm going to go ahead and open up or spit out the build.gradle file real quick just to double check, and there we go. So I've got my App Engine configuration block here. This is defined by Google's plugin. So if all goes well, I should be able to assemble my application. I'm going to go ahead and create our executable jar file. And you could obviously run this with just java-jar, and that's a perfectly valid way of deploying it. In fact, if you go to our booth, which I do recommend you go and check that out, we have some applications there that are running on Raspberry Pi, and we just created a script that, a service rather, so when the device boots up, it runs java-jar on our Micronaut application, and that's how we're serving our raffle form. Okay, so that's all done. Again, I apologize, I can't really read my screen, so let's go ahead and see if this is in my history. So I believe it is App Engine Deploy. There we go. So this might take a minute or two. So let me see if I got anything else that I can show off real fast. Let's see. Oh, so I mentioned those management endpoints earlier. I have a couple of them open here. Firefox has really nice JSON viewing, it turns out. And so it's nice for checking out endpoints like these. So this here is the beans endpoint that I mentioned. So this is giving us information on all the beans that are in our context. So you can imagine this could be quite useful for debugging purposes. And then similarly, we have an endpoint that returns all the routes in our application. And a lot of these routes, in this case, many of these routes you can see are actually being provided by the management library itself. So there's beans, there's env, which exposes environment variables, and a bunch of others. I don't see any of my own. I don't think this application has any of its own controllers right now. Close that now. Let's see. Okay, we're still doing the deploy there. So we're just about to the end here. Why don't I jump back to the slides, and we can sum up a few things and then check back and see if our application is on the cloud yet. Okay, so I know I went through a lot of things, but there are a lot more things, and there's still more things that wouldn't fit on this slide. So there's Micronaut integrations for Kafka, for JAX-RS, for Elasticsearch, and for Cassandra, RabbitMQ, GraphQL. And there's more coming on all the time. So the community around Micronaut is very active, and there's a good chance that if there's an integration or a library that you're using or interested in using, Micronaut likely has something for you there. So all of these, by the way, are links to the documentation for each of these libraries. So we have very robust documentation available for all of the Micronaut ecosystem. And so, I recommend that you get these slides and use this as sort of your launchpad, no pun intended, to learn a lot more about what's available. The Micronaut security library, which deserves an entire talk of its own, supports HTTP, just basic HTTP auth. It supports server, the word's escaping me right now. It supports both stateless authentication as well as stateful. And it's the way that we prefer to use it is stateless using JWT. So that's it gives you some very similar conventions to Spring Security, in fact. So that's definitely worth checking out if you have a security system that you need to implement. Let me see if we're done here yet. Still updating the service. That's just normal for Google Cloud. So let's go ahead and summarize, and we'll see if at the end here we can see our little app. So in summary, Micronaut is a full-feature framework. So this is not just a kind of edge case proof of concept thing. This is a framework that is very full-featured and has the capabilities to serve as a very robust robust option for microservices and for other kinds of applications. Not just microservices, as we were saying. And it's actively evolving, being developed. Micronaut 2.0 is in development, and every version has seen performance increases. 1.3.1 was an improvement over 1.2 and so forth. So we expect it to keep getting better. And I highly recommend that you join our GITTER channel. That's where the development team hangs out, the engineering team, as well as a lot of active community members. So it's a great place to learn more and to get help, and also if you're interested in contributing. It's a great place for that as well, of course. So check out the website, micronaut.io, as your starting point. Of course, you can find the documentation, and you can find the Micronaut guides. So the Micronaut guides are step-by-step tutorials that have most of the things I showed you briefly on a slide. There was a guide for pretty much all of them, and I just didn't have time to go through each one, obviously. And so those guides will take you step-by-step through implementing these features. Most of them are available in Java, Kotlin, and Groovy, so you can even pick your language. And then there's a cool community contribution, a GitHub repo called Awesome Micronaut, which has a bunch of really cool libraries and tutorials, articles, things along those lines all in one place. So I recommend you take a look at that as well. And then in our GitHub repo at Micronaut Projects, we have a example directory, an example repo that has a bunch of sample projects you can check out that demonstrate some of these features. And the one I wanted to highlight is our PETSTORE. This is sort of our reference implementation. So it's a microservice architecture. It's using a couple different programming languages. It's using several different persistence options. It's using JDBC. We're using Redis. We're using MongoDB. So you can kind of see a whole suite of applications working together. It's rendering out a UI that you can interact with. And so I highly recommend you check that out if you're looking for a more real-world example from the Micronaut team. I mentioned the GITTER community already, so do recommend you join that. You can learn more about my company, Object Computing, at our website. We do a lot of training, as well as we keep a running list of conferences that we're going to be speaking at and where we're going to be featuring Micronaut. And thank you very much. Let's go ahead and see if Google Cloud is done. And oh, it looks like something failed. Well, no worries, because if everything's still the same here, I did cheat, I admit. But let's see here. Here we go. Oh, server error. Well, that's not nice. But anyways, I'll have to look into that later and see exactly what went wrong. But if you've ever given a talk before, you know how demos work. So I thank you again very much. I'm just going to see if I see why it failed. Okay, looks like I had the wrong version of Java. Well, oh well. So come see our booth. We're downstairs outside of room 307. So we're kind of on this end of the vendor hall. And thank you very much. The slide URL is right there, bit.ly/micronaut-launchpad. So the slides aren't there yet, but they will be soon. So screenshot or bookmark that URL, and this slide deck will be available. And thank you all very much for coming. I'll hang around if anyone has any questions, or come by and see us at our booth. We'll talk more. So thank you.